Electronic configuration. What is electronic configuration? The electrons are arranged in various energy levels or shells that surround the nucleus. Okay, suppose if you take an atom, we know that the nucleus is in the center and we have the electrons around the nucleus. Okay, but where are these electrons located? The electrons are actually located in various energy levels around the nucleus. Okay, and these energy levels are said to be also called as levels, and they can accommodate different number of electrons. Okay, so say for example, if you take level 1, it can accommodate a maximum of 2 electrons, whereas level 2 can accommodate a maximum of 8 electrons, and level 3 can accommodate a maximum of 18 electrons. The chemical reactivity of the elements depends on the order of the energy levels, order of the electrons in these energy levels. So whenever they form, whenever these atoms combine with the other atoms to form molecules, it is these energy levels that are very important. Okay, so let's go on to the representative elements. If we go on to the representative elements, we can see that this is the alkali metals, this is the alkaline earth metal, and we have the noble gases and halogens. Okay, so how do we find the different shells? So basically, if you find an atom here, if you want to find the number of shells that it has, it's actually the period number. So here is the period number. If you want to find the total number of shells that it has, it's just going to have a total of 4 shells. Okay, suppose you pick an atom here. How many shells does it have? So you draw a line here, and it's going to point to 2, which means it's going to have a total of 2 shells in it. You know, what are valence electrons? Valence electrons are the electrons that are present in the outermost shell of an atom. Okay, and the valence electrons are very important because these are the electrons that are involved in forming chemical bonds. So if you want to find the total number of valence electrons an atom has, you just needed to look in the periodic table and find the group number. Okay, so here is the periodic table. If you want to figure out like how many electrons does this atom have, if you want to find it out, like then just draw a line vertically. It's pointing towards the group number 2A. So the total number of valence electrons that this atom has is 2. Not only this atom, but anything in any atom in this column is going to have a total of 2 valence electrons. And what about this? How many valence electrons does these atoms or does these elements in this column have? It's going to be 6. Okay, so the number of electrons in an atom is the same as the number of elements, number of protons in the atom. So you can imagine that the atom is an electrically neutral substance, and therefore the total number of electrons is going to be equivalent to the total number of protons. Okay. Okay, so here is the electron shell distribution for periods 1, 2, and 3. So hydrogen, it's going to have 1 proton, and because it's electrically neutral, it's going to have 1 electron, which is going to exist in the first shell. Okay, if you take helium, it has a total charge of +2, which means 2 protons, and the 2 electrons will be located in the first shell. Okay, when you take lithium, which has a total of 3 protons, there should be 3 electrons, and these 3 electrons are actually located in 2 shells. Remember, the first level can only accommodate a maximum of 2 electrons, and the second level can accommodate a total of 8 electrons, but because there is only 1 electron present, that 1 electron needs to go into the second shell. Okay, let's do another example. Let's take oxygen. Oxygen has a total of 8 electrons and 8 protons. The protons are concentrated in the nucleus, whereas the electrons are around the nucleus. So we know that it has only 2 shells because the first shell can accommodate 2 electrons. When you subtract 2 from 8, it's going to be 6. But since the second level can accommodate a maximum of 8 electrons, the remaining 6 electrons can go into the second shell. Now let's take magnesium. Now magnesium has a total of 12 protons and 12 electrons. Now where are these 12 electrons are going to go? So let's do this. So we have a total of 12 electrons and we needed to fit this in the different levels. So level 1 can accommodate a maximum of 2 electrons, and level 2 can accommodate a maximum of 8 electrons. And how many electrons are present in level 3 of magnesium? Okay, so we have used a total of 10. Okay, so 12 minus 10 would be 2, so there would be a total of 2 electrons in the third level. Okay, I hope that you guys are able to understand this. Okay, and the periodic nature of atomic size. There are several properties, periodic properties, that goes on in the atoms. Okay, so one of the important properties is the atomic size. What happens to this atomic size as you go from left to right of the periodic table and as you go from top to bottom of the periodic table? Okay, so here is the little version of another version of the periodic table. Okay, so as you go from left to right of the periodic table, the atomic size is going to decrease. Now, what is the reason that the atomic size is going to decrease? The reason is because there is going to be extra electrons that's going to be added into the same shell. Okay, so maybe we'll have a look into this. So you can see that there are only 2 levels in all of these elements. Okay, but as more and more electrons are added into the same shell, that the electrons are actually pulled in by the nucleus. Okay, pulled in towards the center, because of which the atom is going to shrink. Okay, so as you can see, as you go from left to right of the periodic table, the atom is going to shrink in size. But what happens as you go from top to bottom of the periodic table? The atomic size is going to increase. Now, what's the reason behind it? As you can see from here, from this chart here, let's take hydrogen. Hydrogen has only 1 level, whereas lithium has 2 levels, which means increase in the size, or increase in one more shell. Whereas if you take sodium, there are 3 levels. In order to accommodate the increasing energy levels, the atom needs to become bigger in size. And that's the reason you see that the atom, as you go from top to bottom, the atomic size increases. Okay, so this is one trend that you have to keep in mind. As you go from left to right, the atomic size decreases, whereas as you go from top to bottom, it's going to increase. Now let's see what is ionization energy. Ionization energy is the amount of energy that it takes to remove an electron from an atom. Okay, so it is basically you are trying to pull an electron from an atom. But when you try to pull an electron from an atom, you need to supply some energy. Okay, and you cannot just simply pull the electron without doing your work. Okay, so ionization energy increases across a period due to additional protons that are in the nucleus. Okay, so when you look into this, okay, so here's the simpler version of the periodic table. So as you go from left to right of the periodic table, the ionization energy is going to increase, which means you needed to supply more energy in order to remove that electron. Okay, and that's because, remember, the electron that the atom is shrinking in size, and more electrons are pulled towards the center of the nucleus. And if you want to remove that electron, then it's going to take more energy. Whereas if you look into this this part, like where going from top to bottom, you can imagine that cesium is going to have a bigger atom. Cesium is bigger compared to hydrogen. So this electron, okay, cesium is going to be bigger when compared to hydrogen. Okay, so imagine the amount of attraction that this electron is going to have towards the nucleus. Okay, it's going to be very, very less, and therefore this electron can be pulled very easily, and therefore it is not going to take more energy to pull that electron out from the atom.